We were very fortunate, and I recommend highly any kind of effort where you want to accomplish anything in a short period of time, have people co-located. I know we have information technology these days, but it's not a substitute. You can walk down the hall and grab them. They're physically not too far from you. You don't have to try to track them down. They're not answering their cell phones or whatever. But it's very important, very key, and develop an interpersonal relationship. You need that co-location to be able to build a team, because you really had to build a team very rapidly from people from disparate backgrounds, a bunch of prima donnas, of which I was first among them, I'll admit, in terms of being that way. It's like herding cats, the old expression. You had people with very strong opinions, most of whom were at a point in their career where they didn't really have to prove anything, and so, you know, that's another management challenge that some of you may not have, but that was quite difficult. But the thing that worried me was the team was going to go to all the 4 winds and information be lost. We had everything on server. We documented everything. That was a real key thing, I think, in providing that the report and the appendices and all the supporting materials on the server are available to anybody in this room, to anybody at the centers who are approved to log on and get it. But the thing that really, I think, wasn't preserved as much, that needs to be preserved, and I think is being reconstituted to some degree, is the integrated analysis capability. I mean, we were able to have apples to apples for I've done these sorts of studies all my career, and having the capability to have it be co-located, do apples to apples analysis with the same tools, the same methods, and the best tools and methods available, the best people in the agency available, co-located, are you know, utopia for doing this sort of thing. And whenever you're making decisions, it's such an integrated thing. I mean, you wiggle one little thing here, or you know, one thing pops up, you step on it, and something else pops up here, as Joe was talking about the other day. And so when you make trade studies, you do trade studies or try to alter pieces of the architecture, you affect everything in often unexpected ways to stay within a very tight box of cost and that sort of thing. So that's one thing that maybe didn't transition as well, that I think is being recognized and being developed now within ESMD.
But some of the things that we saw from a cost implications was we began to see the infrastructure that HyperGolfs has in the agency from a cost perspective. That, for example, things like white sands and things like Carrie McCluskey would talk to me about the scape equipment that you have to have down at the Cape. And if you see how that embeds all the way through the agency, and how if you make the change to something that's green, some sort of green propellant, you can save the money there, and even though you might get a slight risk advantage or a maturity advantage from going to a HyperGolf system, overall from a cost, if you're trying to fit into a cost box and then an integrated safety box for lunar missions, it may be better to do one thing or another, or at least if you're going to make the decision one way or the other, you need to know the implications in an integrated fashion from one end to another. Doug talked about how it's important to get these turnarounds so quickly. No, John did, I'm sorry. Turn around so quickly, and to see, but Doug talked about how the implications showed up, and I described it as making sausage, that if you squeeze one end, it comes out in another end, and you always had to go sort of levelize it. Now, that means that the risk was, in those cases where the risk cost you something in performance and dollars, that you had tried to levelize it across the design, and one of the things we saw was that because of the nature of the agency in the interim, being primarily an operational organization, there were little pockets of risk mitigation teams in either, for example, the biological area and the MMOD area that really hadn't been integrated across the agency, and they were doing the best they could, but what they were doing was they were adding weight to the vehicle, which was implied a worse launch vehicle, which made a worse risk. Even though they were mitigating risk on their end, they were increasing risk, substantially increasing the risk in the architectural sense. So we had to see that in an integrated fashion, and I think that having been co-located and having these tools to be able to turn things around quickly, and having risk, cost, and performance all in one tool was very important to us.
Another thing that was brought up was documentation. I can't emphasize that enough. In documenting your assumptions, we ran so many cases. I mean, in terms of, we had to do reliability on, we had to do, particularly cost was the worst. I mean, so many trades on cost you had to track. And you had to document your assumptions so that you could keep them straight. And when you go from one step to the next, you need to know what changed. And that is so important, and it's so important from ESMD's standpoint to since this was the baseline coming out, July 31st, 2005, any changes you make now to that, document what happened and why, and what assumptions you're doing. Whenever you do any trade study of any sort, you need to understand what's changing and why, and what things should be changing to do a comprehensive set of trades and why.
The other thing I would say is we did have some problems with center people being able to keep up with the kind of schedule we were doing. But when that occurred, because of Mike's letter and because of Doug's letter of marque, we were able to exert a lot of influence and turn things around. So, that was we didn't have to call upon that often, but it was there in the background. Everybody knew it every once in a while. And lastly, the ability to dump things onto wind chill or ice or whatever you want to call it overnight. Sometimes we would work late into the night, and then another shift, let's say in California, for example, would still be working, and the next morning we'd have it done on wind chill, and that was a very important thing for us because we didn't waste 3 or 4 hours.
Yeah, all 300 people had access to the same server. There was one central repository of data, for one thing. And it's very different from where you are now, too, in the sense, though, that you had the centers have program management responsibility. We had the authority up at headquarters. I mean, all authority essentially was here and final decision making, so we didn't have to worry about centers politics or interaction between program offices because we had all of the authority up here.
I want to cycle back a little bit. I started out in ESMD working for Mike Lembeck writing requirements. And when ESMD first started up, it was a very structured requirements process where we were trying to take the vision for space exploration and write level 1, level 2, level 3 requirements and do it in a very structured fashion that the Admiral at the time was very familiar with. When Mike Griffin came on board, he had a different perspective of what requirements are and how you handle them. He was not. He didn't hold himself to levels. He knew what things he wanted to control, and and whether they were level 1, level 2, level 3 didn't matter to him. For example, if he thought that we knew more about the outer mold line shape of the CEV than anybody else, he said that should be in the requirements document. We should control that. Doesn't matter what level it's at. He was adamant that he wanted an airlock on the lander when we went to the surface. So even though that would be a lower level requirement, that's one he wanted to control, and he gave us that input. He gave us, as Doug said, a lot of other higher level inputs about the character of the architecture that he wanted to see. He wanted us to choose a CEV that would be that would have enough volume for any mission that we could possibly imagine in the next 30 years. Because we only get a chance to build one new mold line about once every generation. So we had some high level architectural guidance, and then I think we did more of the performance and the analysis work, and then we let the formal documentation of the requirements follow at the very end. And to be quite honest, that's one of the things we ran out of time. When we got around to July in this study, we had put in about 2 weeks of writing requirements just as a way of trying to document where we were, and that was probably the one thing we didn't finish to my satisfaction. But I think a couple interesting things came out of that exercise. Number one was the idea that levels were no longer sacrosanct. That you could have a requirements document that was held by the administrator that had requirements at very many levels in it. The other thing that came out was we actually produced 2 requirements documents from ESAS. One was the architecture requirements, and one was the CEV requirement. There was no segment level anymore. We dropped the whole idea of segments as, in the classic NASA hierarchy, of mission segment element. And that still holds to today.
Our job was to formulate an initial set of requirements, and because of the time, because of the resources, you try and reduce the uncertainty associated with the formulation of those requirements as much as you can, but because you didn't go down to every nut and bolt, you didn't identify how many rungs were on the ladder, there's always something potentially when you take a harder look with a more diverse group that's going to come back and bite you in the ass.
Right, but what I'm struggling with is, I think one of the problems we're having in the requirements is now that we're executing and going out, we have lost the centralized ability to do
Because,
grades.
yeah, as nice as the ESAS report is, it's a piece of dead paper. It's not a living, integrated analysis engine that you basically can hand over and say, look, we might have missed something. Play the what-ifs within this framework.
But that's where we are, we need to do
And that's what we need.
Well, I have the luxury of making a recommendation without having to be judged by NASA Center Politics, since I'm no longer a part of NASA. But I really think that a capability like that at the architecture level needs to be led out of headquarters to avoid the center politics personally. And I think you need the equivalent at a representative located within ESMD of a Joe Frigola substitute, a Joe Hammaker substitute. You need a requirements person, you need a cost person, you need a reliability and safety person, and you need someone who's your kind of architect type person too that pulls it all together. You do have information technology now. I mentioned the value of co-location. You don't have the luxury of that as a continual basis, but with current information technology you can have a virtual ESAS. The models are there, the information is here, located on servers here. So, you know, I think that's something that really is a headquarters type function personally to go forward to get around, you know, the influences of center politics.
One question. The systems engineering integration contract was trying to do a lot of that standardization, so is that kind of something you would recommend to continue as a standardization of tools and processes? This is the whole modeling sim world.
I once saw Mike Rendine back during STI put up an honest, no kidding, this was actually the structure of the Delta 180 program that was run by Mike Griffin, was the first intercept of an object in space, proving it could be done. It was a spaghetti bowl. There were lines everywhere. No rational person would look at that org chart and say, it's impossible, it won't work. The simple fact is it worked fine when it came in ahead of schedule and under budget. Anything can be made to work. The details are in execution, not in the theory of management.
I guess I'd rather have a simplistic model now that gives me some type of top-down understanding of the overall system behavior than spend 2 years developing the hell out of an integrated platform that's web-based that does, you know, and find out, well, okay, I'm 2 years too late in finding out what I really needed to know.
I'd rather have simple tools and people who know how to use them down to the nth degree than complex tools that no one knows how inputs turn into outputs.
Let me speak directly to the tools question, because one of the studies that I'm running in PA&E is a tools study in which we have recently documented that there are, as I recall, 562 different management tools at use in the agency, 360 of which are duplicative of each other. Any tool will do.
I think someone else is doing that study too.
Okay, let's...
3 other teams are doing that study too.
First, let me say that to some degree, the ability that we had to do the risk part of this in an integrated fashion, I have to owe to Doug Morris of NASA Langley, because about 7 years ago, he had read the 1995 PRA that I did on the shuttle, and he said, you know, this is a really interesting thing, Joe, but you think you could somehow convert this into a functionally oriented Lego block type of system where we could take the models and put pieces of them together to make new launch vehicles and look at new engines and things like that? And would that be a useful thing to do? And we thought about it for a while, and we said we certainly could do this. It requires what you do after you create the risk models of a design. What you do is you reconstitute the models in terms of functional links rather than in terms of elemental links rather than functional links. And then you rebuild the model and check to make sure that you get the same risk. And once you do that, now your elemental things can be sort of pulled out on block level and be used. And they're faithful enough to give you some representation. How good it was a question that we couldn't answer for Doug. And I said, Doug, we could do this, but I can't guarantee success because maybe the shuttle is so different than the new launch vehicle that when we put it back together, it wouldn't be represented. Well, it turned out that didn't get funded, but the idea germinated in my mind, and we plugged along with a little bit of in-house work and funds that eventually came from NASA Ames and out of the systems engineering group out there, Donovan Mathias and Mary Livingston, gave us the funds to essentially deconstruct the 1995 shuttle study and then to build conventional launch vehicle models from that study and to see how representative they were and to see if the risk estimates were reasonable reconstitutions of those risks. And it turned out that they, to a great degree, they were. They weren't exact by any means, but it gave us enough, as Blake Putney likes to say, enough information to know the differences that made a difference in the decision-making process. So when you look at ESAS and you look at all the numbers of the risks, don't think of them as real numbers, but think of them as a what we call a coherent set to allow us to discriminate between designs. Well, we took that work that we had done on some of the conventional launch vehicles, and then Bill Cirillo funded us for a number of years to take that along with the shuttle to build a transportation architecture to sustain the station and to investigate the station delays. So we had all these models were continually being developed in a logical modular fashion, so that when ESAS came along, we had that all in place. And it was really, even to me, remarkable how many different configurations of launchers, and then later on, LSAM propulsion systems, ascent and descent stages, EDS ascent and descent stages, SPS type of configurations we were able to do using this top-down systems concept. I think we counted at one point in time, in terms of the number of launcher configurations that we looked at, we had done something like 27 or 30,000 different combinations. And what we did then is we had these logical Lego blocks that we could put together to make things, and we formulated all the possible combinations, and then we used the intelligence of, in terms of the launchers, we used the intelligence of Steve Cook and his people and Phil Summerall and their people down at Marshall to build what we called extinction rules that extinguish certain combinations before the fact because they didn't work. You know, you just couldn't put these things together and get the payload that you wanted. And so we didn't realize it, but we had created some sort of a genetic algorithm where we created all these combinations, and then we built these extinction rules that extinguished some of them. And so we looked at a lot of them very, very rapidly. And the first thing was to make it work. That means to make sure you got a certain payload off the ground with the configuration. And in some cases, you just couldn't. And then to make it reasonably reliable and from a risk, loss of mission, loss of crew standpoint. And in doing so, we took the 30 or 40,000 combinations and came up very rapidly to some 24 configurations of launchers that we looked at. In addition, we had done a study for ATK on the single stick before that, so we understood the single stick pretty well. And in doing that single stick, again, we used this Lego block approach. But in that case, we deconstructed the SRB contribution in the shuttle from the shuttle PRA to look at the single stick contribution, eliminating failure modes that were due to the fact that you had two SRBs, eliminating some other failure modes, and then reconstructing the model of the vehicle. And one of the things that it turned out to be good on was that even though we knew in our heart of hearts that the numbers we were coming up were not going to be the real numbers, quote, for the SRBs or for the different launches that we were constructing, we knew they were good enough to discriminate certain features. So that was the first thing. If we did not have that, we would not have been able to do this study. Now, the one thing you don't see on that page, what's the name? Table, whatever it was?
8-9.
8-9, is that we had a strip on the bottom that had cost. We had to strip that out because sensitivity of it. But you can, if you put in cost into that, then you can see the cost growth. And then what happens is that you see peaks that they're unacceptable. You squish down the peaks, and you move things out, and you see the risk go up. And then you squish down the risk, and you see the performance go to heck. So, you know, that's the kind of play. And to me, you, as an individual, should have a little gaming machine you can play with on your desk. You know, that's not exactly perfect, but can play around with these Lego blocks to keep your team honest. Not because they're nasty people, but engineers love to do local optimization, and they have a very great difficulty in understanding global optimization in terms of local. So you can keep them honest by putting their number in and seeing if you get a big peak somewhere else. And believe me, that is really helpful.
Just one last thing on technology while we're on the topic. A lot of people, some of you in the room may work in technology and may be cursing ESAS and having sliced the technology budget by a factor of 2.
My name is Mud, yeah.
That's why Jay's working in PA&E now and not ES.
And in that office, we refer to him as Dr. Mud.
Obviously, the problem we had, and this is coming directly from the administrator, was we had to accelerate the CEV to have a program,
Yeah.
in his opinion, to have stakeholders like Kay Bailey Hutchinson and Tom DeLay support it. And to do that, of course, requires money in the near term. And the technology program had a couple of $2 billion a year over that period of time, and so we had to, cut it back significantly. So technologies really had to buy their way on the vehicle. And Mike, by his very nature, is a results-oriented, do it as low-tech as possible, KISS, keep it simple, stupid, make it work type person. And so I thought you didn't need any advanced technology. I mean, you obviously need things like the Apollo suits only work for a few days. We need a suit that works for 6 months. That's an enabling type stuff. But anything beyond pure enabling was very difficult to fund. No more sandbox.
I think Scott actually got this action already. I think there are, in many ways, ESMD operates the way ESAS did, except at a much larger scale, with a much more diverse workforce spread all over the country. So there's no reason why many of the same techniques that ESAS used can't work for ESMD, except scaled up appropriately. One of the techniques that worked very, very well for us that I think we absolutely need to continue is the use of multiple performance metrics to make decisions. And so I would suggest that anytime ESMD wants to make a change to the baseline architecture, well, first of all, you should have a baseline architecture. You should fully understand what its risks are, what its costs are, how technologies buy down those risks, how precursor missions dial into it. And any changes you make, you should calculate what the changes in all those other metrics are. You should fully understand what the performance changes are, the cost changes, the risk changes.
All elements.
All the elements, right. Don't look at global optimizations. Or local optimizations. Look at the global picture. I'm afraid that we've already been caught in an analysis cycle where we've made some local decisions without looking at the global picture. So we may have to back up a little bit and get some of that analysis work done. So my parting shot would be to, and I think Doc seems already to embrace this, is that just doing performance analysis or doing a little bit of cost analysis or a little bit of risk analysis is insufficient. You need the capability to do all of those and to integrate them together in your decision making.
Always remember that the perfect is the worst enemy of the good enough. One of the things that made us successful on ESAS is that we were willing to go with models that we understood were not giving us, quote, the risk. They were giving us an idea, enough of the differences between designs so we can discriminate between designs and make decisions. What I found in the agency is people try to make the designs way too faithful, and in doing so sacrifice the breadth of analysis that's necessary at this stage of development. And someone asked the question before about the simulation models and how they fit into all these things. And simulation models are good once deep simulation models are good once you've selected a design or an architecture and so on, but you shouldn't concentrate on faithful simulation models in the development of alternatives unless they discriminate a difference that makes a difference in the selection process. And we didn't get to talk about uncertainty. On all of these things is a reasonable amount of uncertainty, but always remember that what we call the expected value of perfect information. That means if you reduce the uncertainty to 0, would it change your decision? In many cases, it doesn't. And so the investment necessary to do that is not really a useful investment in terms of the decision-making process. And I've seen that many, many times, that the agency wants to go and get better models just for the sake of making better models. It's not going to change the decision. And wishful thinking isn't going to change the decision either. So just because you have some sort of a wish you may know in your heart of hearts by running the finer simulation you're not going to change the decision, so it's better to take the hard decision now. 5 or 10 years ago, I wouldn't have said, with the degree of certainty I feel now, that these Lego block or functional in-out models were good enough to support decision making, but now I really believe they are, because I've seen them work over and over again, and I think that high level of model is a very important adjunct to the lower level models that you use later on when you got a design defined. So the type of modeling you need to discriminate is different than the type of model you need to analyze an actual design. So I'm not being negative about these kinds of models once a design is chosen, but there's a difference between scoring an existing design and choosing between alternatives, and that's an important thing to remember. And I think that's a lesson that paid us well in ESAS. We couldn't have done all the analysis that we did on the many different designs that we had if we had chosen to have these real perfect models.
I don't think I can overemphasize the importance or the power of having the combined probabilistic risk assessment and cost integrated into figuring out what you're going to do.
Sir, could you speak up?
No. It is astonishingly powerful to be able to have those two together, and having seen it work, I would say, you know, one is essentially wandering around blind if you're not doing that.
And let me add just briefly that, since Joe's here, and I wish the other Joe were here, is that it's not just the models either. It is the individuals, it is the people who have lots of gray hair and lots of experience and have a system perspective.
Yeah, that's true.
And all those are necessary conditions.
The intuition is important.
Yes, it's informed intuition that you have to work at in this phase. And so we get wrapped around the handle of this agency about making better models. And people run models, come out of college, run models, they have no idea what's behind them. And it's just garbage in. Every model is garbage in, garbage out, particularly in the industry we work in, because we don't have a database of, you know, tens of millions of flight hours of a commercial aviation or a military aircraft. We're building a new military aircraft. We're building something that we've only done 2 human spaceflight systems to do, and there are over 30-year or 40-year differences between each. And the one we have now isn't something, you know, we can keep the cost of. We got to do something a lot better. So it's having the people and the individuals. So it's not enough for ESMD to have this capability or have these models. You need the smart drivers up here also, the right people who have a system perspective, have experience, and are architects.
You want to be very, very careful about your infrastructure. You know, yeah, we took the Saturn infrastructure and we modified it for Apollo. We embedded very, very large costs in shuttle in consequence of using that infrastructure. At the Cape, cost is highly tied to buildings. If you want lower infrastructure costs in your new system, you got to knock down buildings. And any story with regard to how we're going to build, you know, what we're going to do for infrastructure for the new architecture that involves building new buildings and not tearing down equivalent, you know, square footage 2 to 1 is not improving the situation. It's only making things work. Every building down there comes with people in it and fixed overhead costs. So first rule of thumb is don't, you know, you got to knock down buildings in order to have lower infrastructure costs. Allow me to observe that institutionally the Kennedy Space Center has no reason whatsoever to raise its hand and suggest knocking down buildings as the next smart thing that they want to do. So
Firing people.
Hiring, you know, asking KSC what needs to be done in order to, you know, support this architecture is inviting, you know, the fox into the henhouse. It's not reasonable to expect that they're coming back with the lowest possible cost answer, as I suspect we will see next week. So those are some sort of thoughts on the infrastructure side. You know, that whole transition question keys off of what is the future you want. If you think that shuttle is expensive and you want something lower cost, then first and foremost, you've got to head in that direction. And that means fewer buildings, above all. All of the infrastructure stuff from the Cape was basically a throughput. You know, Kerry and Joe and I scrubbed it. We were extremely suspicious of it. We, you know, at the sort of transition meeting that we had, what, 5-6 months ago, you know, I made the point that scrubbing those costs should be high on your agenda. Because even within ESAS, there was not time to go do a very, very careful scrubbing of the costs we were getting from the Cape. Let me tell you something I saw once. I actually worked for Mike in the first Bush Moon Mars initiative. At that point, there was a brief affair, let us say, with the idea of resuscitating the Saturn V. And so we went out to Rocketdyne to ask about the engines. And they showed us, they had assembled it for us, but they showed us a room about half this size, the walls lined with antique 1970-ish videotape of every single person who had worked on the F1 engine talking about every detail of what they did. Wow. It was all there. You know, it's not about blueprints. It's about know-how. And the know-how had all been documented and was available. And that's how you do it. Nowadays we'd use DVDs.
Well, another thing you do is just because somebody leaves NASA doesn't mean they're not available. It's just an economic issue. I mean, I'm here. I left NASA. I mean, you just come back as a consultant, or they're coming back working for somebody else. So unless they die, unless you have a significant amount of people die in that time period, you're going to have access to them. And the ones that are of most value, you don't have to let them go. You pay a little more per hour for them, but you can get them when you want them.
I guess the only thing I have to reiterate is I still see an issue for ESMD, SOMD moving forward to understand how to deal with technology, because NASA has two cultures. We've got development and flight, and we've got research and technology. And I saw during ESAS, and we had some great team members like James Reuter running back and forth to the centers trying to say, what work can you do? How will you use it? And even with people trying to do that, there's a mistrust, and there are some barriers that we still need to work on breaking down so that we can say, there's two kinds of research projects. There's some kind that are in the critical path, and I'm going to need this, and I'm going to need it when, and we need enough communication to make sure people can plan on using it, and it gets there. And then there's the kind that are going to be further out, and we're going to say we can do something better next time. And obviously a lot less dollars go into that these days. But we need communication on which type you are. The researchers need to know it too. They don't want to be strung along and changing direction. And we need better communication on this.
A bit differently.
Yes.
Yeah.
There's three great opportunities for making money. One I've talked about, that's at the Cape. The other's the lander, which John's been working on, and where I think just plain innovative thinking is going to be required. And the other is getting rid of the SSMEs on the heavy lifter. And that one, of course.
You don't like those unit costs?
$47 million each when I can buy an RS-68 for 14. Looks like money to me.
The major point that we've all emphasized as a wrap up is that we need an integrated capability to look at cost and risk and everything throughout the architecture, and needs to not just have the tool. It's not just the tools, it's having the intelligent driver. These guys sitting up here are more important than the tools they use, by far. It's having architects, not builders. There's a difference. I mean, other mature industries make a dichotomy between architecture and construction. In the building industry and even the naval industry, it's a recognized occupation to be an architect. In the space industry, space transportation industry, you don't hear about architects so much because it's not as mature an industry, but it is a valid profession and capability, and we need to consider that as we go forward. And as you establish an architecture, you don't go and, when you get halfway done, make major changes in the model. It's going to affect something else, and your building will fall down. So you got to be careful about that, and only not let the perfect be the enemy of the good, as Joe said before he left. So that may require, we haven't used the word, but a configuration control board is something you have at a project level. You need that at the architecture level, where it's not just people arbitrarily making changes, but there's some system in place to make those changes, and somebody has to put their signature on the dotted line and with the justification for those changes, and impose that sort of discipline, and track specifically what changes are made in terms of configuration control. I talked about, being thorough, credible, and objective. It needs to continue to be that way. And often that's not the case. I worked in the agency, did system analysis for 15 years, and 90% of it I was unsatisfied with, and people either didn't have the tools, models, they weren't doing apples-to-apples analysis, they got a job to do and they just gave a result, regardless of whether it is credible in terms of they had all the data they needed to do it, and they don't share that with a decision maker often because they don't want to look bad. And I think we get into that trap. And I'm afraid we're going to fall into the trap of having the center politics. I can see right now in ESMD, centers are not sharing data with each other. I observe it every day. And that's unacceptable. I mean, you need to have some sort of discipline from the top down that rewards people for cooperating and sharing data, and not otherwise. Often there's incentives the other way, and Bill brought up the point of the perverse incentives that KSC has to not to reduce costs, because then they reduce jobs and they reduce infrastructure and they reduce their power and fiefdom and that sort of thing. So it's really relevant for headquarters to play a role, and a value-added role, and not just create your own fiefdoms and jobs. One of these guys on this team can do the work of 5 bureaucrats. It's getting the people in the right place, and if somebody doesn't have value-added, not having them in the program. Let's not create positions, just create positions, create IPTs and IDTs and all that we used to have, and we got to worry about going back to that. And everyone should have, be doing a job for a reason, and it should be integrated. Again, we get in the situation of 4 different people going off and doing the same trade studies. I think we're doing that right now in the propellant trades. And so it's very important to have a discipline, and that be a headquarters function to pull that together. And personally, my bias is that it be a DIO function, because that's their job, is to be independent. It needs to be independent of pressures. So.